So let us go through that. So curvature will help us to understand the bending of a curve at a given point. So at this point, the bending is less. At this point, the bending is more. So if you take this arc length, then you can see that the curve is bending this much. So the bending, at the same time, we have seen that the tangent, the slope of the tangent is actually changing very fastly from here to here. Okay. Now, if we have, assume that we do not have the graph plotting facility, or for example, online help is not there, there is no software. What we have only is a pen and a paper. Okay. Now you plot this. What will be the structure of the, what will be the graph of the curve? So you need to trace the curve actually, plot the graph. Okay. Then what are the information that you can read? So if you can plot this graph, that means you are good, you are in a good position. But if you don't know how to plot this graph, then this is for you. You need to concentrate on the topic that we discussed today. And also, we have discussed so far for asymptote and then other topics also. Okay. So, for example, if we start, use the trial and error method. Let us write the function in this form. And then, for a given a function a equals to 0, you try to find out the values of x and corresponding y and y square and then y. So if you put y equals to a equals to 0, okay, so this is becoming 0, then it becomes x cubed by minus x. Now if you put x equals to 0, so this is becoming 0 by 0 point. So that is not defined. But if you put x equals to 1, if you put 1 cubed by 1 minus 1, so this becomes minus 1. Okay. So y square equals to minus 1, it becomes. So you will get plus minus root over minus 1. So that again you are not getting any real value. You are getting on complex values. So anyway, that is not a problem. We'll plot the function in the complex pen if possible. But if you take some other points, for example, a equals to 1. If you substitute, then x equals to 0 will give you y square equals to 0 and then y equals to 0. Similarly, if you take, so that means you try to plot the curves, find the points, and then you will substitute the points. For example, here. Now we can see that for a given x, what you are getting, y square equals to some will be something there. But at the same time, y values will be, one is positive, one is negative. So that means if you plot here, the same point will be, the reflection point will be there. Okay. If you put one mirror on the x-axis, then for each value of x, you are getting two values of y. Okay. So two values of y. So this much, but you don't know where to start and where to stop to write the graph. Okay. So this is not this error trial and error method is not that much effective to give you the best idea to get the actual structure of the graph. But if you have some plotting some plotting software, for example, I have used the help of this demos, then you can see the function y square equals to x cubed by 2a minus x. And I have taken the asymptote x equals to 2a. Now if you change the value of a, now you can see that the graph will change its location. So what is happening here? with the help of this graph plotting tool, we can easily plot this diagram or trace this curve. Okay. But if we don't have such facilities, for example, we have only pen and paper, then we have seen that so far we don't have any organized approach so that we can find out the starting point and the ending point and some more valuable important information about the graph. Okay. Now if you look at this problem clearly, then what happens? Earlier we do not have this facility. We don't know where to stop and where to, because how long you can go to change the value of a, x and y. So you don't know whether it is starting from here or if it is going to there also, that we don't know so far. So that is why we need a better approach, and we don't need this graphic tool also. So it is in between them. Okay. We have nothing, we have graphic tool, everything it will do. Okay, so we want to select a basic, so we need to know the idea, some theory which will give you the sufficient information so that you can plot the diagram. Approximately you can plot the diagram and you can know the starting point and then other. Okay. So for any given point, if you for any other graph, y equals to x square 1 minus x square, so we'll have this kind of graph. Then if you put y equals to -1, so this one is asymptote, and then if you put x equals to what, so this is one another asymptote, x equals to -1 another asymptote to the curve. Now with so asymptotes are not the only thing that can guarantee that this is the actual curve of the given function. We need some more information so that we can plot this graph accurately, or better we can say almost accurate, or maybe approximately we can do the correct graph without taking the help of graphic tool. So for that we need some basic definitions. Okay. So when we see some function is of this form, then we can, this position is called a valley type, and if we have of this, so this is called peak type, mountain and valley. So from there this concept has been taken, and the function will be called as concave upward and concave downward if they satisfy this relation. If the double derivative is strictly greater than 0, then we call it a concave upward. That means the function will be of this form. If we have this form, the function, the double derivative of the function is negative, then we call it a concave downward. Okay. Now, what is a concave upward? As we have already mentioned, okay, if you look at the graph of the concave upward, okay, this function is also known as convex function. Later we will discuss again. Okay. So concave upward is meaning is that if you plot the tangent at any point, okay, at any point, if you plot the tangent, then the curve, the points of the curve will be upside, will be above the tangent. The above the tangent, all the points of the curve will be above the tangent. So that is the meaning of concave upward. And for this type of function, we will have always this relation satisfied. So there is another name of this function is actually convex function. In fact, convex is a convex function. Fx if fx is convex, convex is actually meaning concave upward. Okay, there is some for your information. Okay, later we will discuss more about this convex and convex. Then minus fx is concave. Okay. Here we are trying to define any curve in terms of either it is concave upward or it is concave downward. So for concave downward, if you plot the tangent at any given point, then what you can see, the points of the graph, the points on the graph is always below the tangent line. Okay. And for this concave downward function, we will have this relation always satisfied. So concave downward function is actually called as a concave function only. The event is called concave upward and concave downward. Okay. So two possibilities. Either it is concave upward, so that will lead us to convex function. If the graph and if the graph if the is concave downward, then the function is called concave function. In fact, you have started these functions in +2 level when you have started the convex length and concave lengths. Okay. So the same idea actually. Now there are some functions which are neither convex nor concave at some point, at some in given point. For example, if we have this point is called point of inflection. What happens here, if you think about this point, then it is going for a peak. Okay, if you go for this function, this is going for a peak. This is, and if you think of the other portion, then this is going to be a valley. Okay, that means it is increasing, and from there it is actually, if you think in this side, so this will, if you go in this side, so this will be decreasing. Anyway, the function is actually going in this way. But the structure of this function is, at this point, the tangent will be positive and then others will be negative. If you remember, if we have this type of function, then the tangent is actually moving in this direction, then it will go up. Okay. So here, so same thing happened. So at this point, the tangent will be actually intersecting the graph. If you try to plot a tangent at this point, so this will be intersecting at this point. Okay, when we have two tangents at some point, okay, for example, if you remember the function mod x, we say that fx equals to mod x. Okay, it is not differentiable at x equals to 0, because if you try to plot the tangent at this curve, you can have many, but if the derivative exists, what happens? It will have unique tangent at that point. But at this point, you can plot many tangents for this curve. So this is one kind of situation, but not exactly the same. So what happens for inflection point, that if we have an inflection point in this point, what happens? The concavity changes. So it will be concave upward, and after that it will be concave downward. This is concave upward. This is valley type, and this one will be concave downward. Now at this point, the second derivative, if it is continuous, okay, then at this point, inflection point, that f double dash will be 0. For example, if you think about f of x equals to x cube, then you have f dash of x 3x square, and f double dash of x you have 6x. But if you substitute x equals to 0, so f double dash of 0 equals to 0. Earlier, what we have seen, either it is negative or it will be positive. But if we have at that point, that is 0 for the point of inflection, so there geometrically what happens, that there will be the concavity will change its direction. One will be concave downward, another will be concave upward. So that is the meaning of inflection point. Now if you think about, the point is x to the power 4, okay, then this is 4x cube, and this one is 12x square. Now if you just try to look at the diagram, okay, of this point, so if you plot here one tangent, so you will have only one tangent, and it will not intersect the curve. Similarly for here also, it will not intersect the curve. But if you think about here, if you try to plot here one tangent, so that is going to intersect the curve. Okay, so what it means is, actually it does not mean that if we have f double dash equals to 0 at some point, that does not mean necessarily that this point is a point of inflection. So point of inflection is such point where you will have concavity will change. That is the meaning. Okay, so if you need to remember the point of inflection in terms of concavity, it is not in terms of the second order derivative. Okay, So if you just zoom it, then you will see the graph of these functions will be like. So if you think about this is concave upward, this is concave upward. For this red curve also, if you see this is concave upward, here also concave upward. But if you look at the blue curve, this one, here it is concave upward, but here you can see this is concave downward. Okay. Now we move to the next. So I will give you some examples to go through it. I think you will understand. Okay. So these are for basic verification, easy verification. And another easy verification to find out. So these three things, go through it. I'll move to the next definitions. So these definitions are from P.S. Graval, which will help us to trace the curve. Now first we have to understand, because whenever you go to plot any diagram, okay, then you will try to find whether it will be like this, or it will be symmetric about y-axis, or it will be symmetric about the x-axis, or it is going to be passing through to infinity, pass through the origin. So this type of some basic properties which are
Sir,
known as symmetry, then asymptotes, the number of branches and number of points will be there.
sir,
So what is double point? Just tell.
sir, without continuous at a point where curve changes accordingly, shall we say that is a point of inflection, sir?
Can you repeat? I did not get your question. Can you repeat,
Sir,
please?
sir, actually, without continuous at a point where curve changes accordingly, that is concave upward and convex downward. Shall we say that point is a point of inflection, sir?
Without knowing continuity.
Yes, sir. At the
No,
particular
without
point,
knowing continuity, we cannot. Without knowing the continuity, we cannot say, because for discontinuous function, we do not calculate the f derivatives, right?
yes, sir. Yes, sir. At a point where only the specific point is continuous, sir.
Okay, if for a specific point is continuous, then we have to think about the points are actually. So here, if you go through these three examples, you will look at this point actually. Yeah. So let me just give you. For example, f of x equals to x cube. F dash x 3x square, then f double dash x is 6x. Now, if you try to find out the definition, what is the definition? At the point of inflection, for example, P, C, comma, f of c, f of c at this point, f double dash c minus h and f double dash must be of opposite sign when h greater than is sufficiently small. Okay. Now, if you try to look at this function, let us note. So, assume this is x cube, and here c equals to 0. Okay. So, what is it here? C f of p is our 0 point. It is continuous point. Okay. C f of c. So this is our p 0 comma 0. Okay. Now what we want to say, f double dashed c minus h and f double dashed C plus H. So C is 0 here and C is 0 here in our case. That means we want to find out the f of minus h and f of plus h. So if you use the derivative limiting definition, limit h goes to 0, f of x plus h minus f of x divided by h, right?
Sorry,
Limit.
f dash of x plus h, no, sir.
Oh, this would be f dash. Okay, right. Okay. So if you just, yeah, right. F dash x plus h and then f dash x. Then, so what will happen? So f dash of x is our this one. In this case, okay.
F dash of x minus h, sir.
F dash of
X minus h, sir.
x 6. So this one.
Yes, sir. For first derivative, f dash of x minus h minus f dash of x by minus h will be there, no, sir.
Yeah, then it will be minus h.
Yes, sir.
If you substitute, this will be plus h. So these two derivatives, okay, if you consider the neighborhood about the 0, this is 0 plus h, 0 minus h. Okay. So if you consider this interval, at some point you are saying that this is negative, and at some point you are getting the positive. So this is the actual meaning of. Now, when you have a discontinuous function, for example, if you have a function like this is a discontinuous function. At this point, you cannot check the concavity or convexity because you don't get you don't have sufficient permission to get the derivatives. At this point, you will not be able to find out the first order derivative also. Then how can you go to second orders? So whenever we talk about convexity and concavity, we assume that this point is actually continuous at that point. Whatever you have observed is actually correct. Is it clear?
Yes, sir. F double dash of x might not be continuous, no, sir. F double dash of x.
Yeah, it might not. Yeah, might not be. It will not be continuous. If it is a point of inflection, then it will have two different sign. Okay, see here. If it is inflection point, then these two values will be opposite sign. That means they are not equal.
Yes, sir. Okay, sir.
Okay, but at this point we can see that this is equals to 0, but it does not. Hence, if it is continuous, okay. But in a different example, if this is 0, that does not imply that this is going to be inflection point. Okay. Because
Okay,
if you look at this, look at the derivatives, they will have the same sign. Hence, x0 is not a point of inflection. Okay, so I move to the next definitions. These are called, one is called double point. When you call it a double point, a point through which two branches of a curve passes is called a double point. So it will look like at this point, one branch, another branch will pass. So we call it a double point. What is the note? If the tangents are real, and distinct, the double point is called a node. So here you can see this is a node. In fact, for node you will remember it will look like a knot. What is a cusp? Cusp is if the tangents are real and coincide. That means you will have a sharp peak of this form. Here the tangent for this curve is this one. Tangent for this curve is also this one. So what happens here? The tangents are real and they are coinciding at this point. So this is called cusp. We have node, we have double point. Okay. Now, if we have a complex situation, then we call it there is another called conjugate point, or we can call it an isolated point also. If the tangents are imaginary, for example, they do not have real values, slope, and the double point is called conjugate point, or it can be called as isolated point. Such a point cannot be shown in the figure, in this figure. In the two-dimensional space, we cannot show it. So this is for mathematical idea. Now, when we try to plot any graph, then we must know the symmetry, whether it will look like this, this, or this. To which axis it is symmetric. So, in order to understand the symmetry, we have to, for example, if it may symmetric be about this line also. It may be symmetric about this line. So, this symmetry is very important to plot the graph. So, first, a curve is symmetrical about the x-axis if only even powers of y occur in the equation. For example, here it is. Even powers are happening for y, but x has odd power. A curve is symmetrical about the y-axis if only even powers of x happens. For example, here. Now, in any curve is symmetrical about any line y equals to x if on interchanging x and y, its equation remains unchanged. So that in that case, so this is symmetrical about y equals to x. That means we'll change in place of x, we'll substitute y. In place of y, we'll substitute x. So here also, in place of x, we'll substitute y, and in place of y, we'll substitute x. And we'll look at if they are not, if this equation is unchanged, then we call this is symmetric about the y-axis. For example, for different case, we may have in place of y equals to some 2x, if you substitute, and it is not going to change the equation, then we call that the curve is symmetric about this line. For a different point of, for a different function, we may have such situation. Then we know, then we have to understand whether the curve is passing through origin or not. If it is not passing, then how far it is. See, if the curve passes through origin. So for that, what we have to do? A curve passes through origin if there is no constant term in its equation. So this is one information which will help us. If it does, find the equation of the tangents thereat by equating to 0 and 0 the lowest degree terms. So how to find? So if we have the lowest degree term, so we'll make it 0 and then we'll try to find out the tangent. If the origin is a double point, find whether the origin is a node or cusp or a conjugate point. So that is very important. Whether at origin, whether the function will be of this form, that is a cusp. If it is not a cusp, whether it is a node. So this in real life we can plot these two graphs only. Conjugate point is not possible to show. So either it is node or a cusp. These two are visible to us. And then we have to understand the asymptote, whether any particular line is asymptote or not. Because asymptote will be, we know that asymptotes are of this line. It may look like they are matching at some point, but if you zoom it here, then again you will get that there is a difference. If you try to find out whether these parallel lines are actually asymptotes or not, then you try to find out the inclined asymptotes. That's one. Finally, the points. We need to find out the points where the curve crosses the axis and the asymptotes. We need to find also the points where the tangent is parallel and perpendicular to the x-axis. Okay. Finally, we need to understand the region in which no portion of the curve exists. So in order to get this idea, so let us understand the example that we have started. So trace the curve, that means you have to plot the curve of this function. So let us try to find the symmetry. First we have to understand the symmetry. So if you want to understand the symmetric property, then what we see, y square equals to x cubed by 2a minus x. So only even powers of y, even powers of y occur in the equation. Okay. Hence, the curve is symmetric about the x-axis. Now, let us understand the origin. Whether it has any constant term. There is no constant term in the equation. Hence, the curve passes through the origin. So, as you can see that this is symmetric about x-axis. So that means you have an idea that the curve may be of this form, symmetric about x-axis, or it can be of this form, or it may be of this form, or it can be of this form. Symmetry about x-axis. So this is one rough idea. Now you have one more information. What is it? Passes through origin. So you have the confidence now. You can take the curve from origin. And since it is symmetric, so you will have these points. Or you can have this point. It can be of this form. Okay, so this is the information till now you have. Now we have 2a y square minus a y square equals to x cube. So from there you can get x cube plus xy square, sorry, ay square. There is x, this x y square minus 2a y square equals to 0. Now what we have to do, the lowest degree term, what is it? What is the lowest degree term? For this is degree is 3. Here also degree is combined degree is 3. So lowest degree term is this one. So let us make it 0. Okay, equate the lowest degree term to 0. That is here minus 2a y square equals to 0. So here we get 2a y square equals to 0. And this is nothing but y equals to 0. What is it? This is a, because a is a non-zero constant. Scalar value. A is scalar value. So 2a is a scalar and y square equals to 0, which implies y equals to 0. So the tangent at the origin are y equals to 0. And not only that, since y equals to y square equals to 0, so we'll have y equals to 0, comma 0. So that means y is a, origin is a double point. And not only that, they are matching. So y equals to 0, comma 0 are the equation of the tangents. That is, origin is a double point in particular. Y1 and Y2, let us call it 0, tangents. They are coincide. In particular, the origin is cusp. Since the tangents are coincide, since the tangent coincide. Okay, so that means we have this curve. So far what we have, the information, the curve is, origin is a cusp. Okay, so that is why we can now, and initially we have seen that this is a cusp is will be like this. It will have a sharp peak. It will not be like this. A smooth peak will not be there. Smooth valley, or you can say and this is sharp. Okay. So since this is a cusp, so we'll have of this form, and it is symmetric about the x-axis. Okay, and y equals to 0, y1 equals to 0, y2 equals to 0 is a tangent. So that means the tangent, this is the tangent. Here it is the tangent. So x equals to 0, sorry, y equals to 0. That means the x-axis is the tangent of this curve. But we don't know whether it is this side or that side. Whether this side or that side, that we have to investigate further. Okay. So for that, we need to understand the third aspect, and that is asymptotes. Given the curve, x cubed plus xy square minus 2a y square equals to 0. So let us write the algebraic form of the equation. This is x cubed plus x minus 2a y square equals to 0. This is the algebraic form. Algebraic form. Now we cannot make the coefficient of x cube equals to 0 because the coefficient is 1 here. So there is no, what is it, horizontal or vertical x cube. So there is no horizontal asymptote. But we can have the coefficient of if we make it 0, so what we get, x minus 2a equals to 0 gives us x equals to 2a is a this gives this says this tells that x equals to 2a is a vertical asymptote, and we do not have any inclined asymptote. So asymptotes are over. So now what we do is we still don't understand. This much we have understood. This is a cusp. Okay. It may be on the left hand side, it may be on the right hand side. At the same time, we have seen that this is going to be a asymptote or vertical asymptote. So we'll put one vertical asymptote. So this is x equals to 2a. If a is negative, then the asymptote will be here. Because a is a scalar value, we have not mentioned whether a is positive or negative. So in order to discard this one of the side, we have to understand the points. The fourth aspect, the points. Okay. So I'll take another 5 minutes. So just wait. It will be over. So first one. So for points, we have first observation is the curve meets the axis at 0, 0 only. So y cube equals to y square x cube by 2a minus x. Okay. Second observation, at no other point for a given particular a scalar value, only x equals to 0 will imply y equals to 0, and both vice versa. If you take any other non-zero value, then you may not get the same situation. So it will only get, if x is non-zero, then y is also non-zero for this function. Okay. So that means only at 0, 0, the curve is matching. It touches. Next, what we have, y
Sir,
square equals
why
to,
don't you consider inclined asymptote, sir?
if you take inclined asymptote, what happens? So for when inclined asymptote, what we have to consider? You remember the topic, the last topic that we have discussed?
Yes, sir.
Tell me, when we try to find out the inclined asymptote. Okay.
We should
Go to
go,
the topic that,
sir,
yes,
by taking x is equal to 1, y is equal to m, we have to find values of m.
yeah, that
Then
is
we should
okay.
find constants.
So if you remember the concept of inclined asymptote, okay. So if you remember this topic, so for inclined asymptote, what we have to consider, we need to satisfy this relation. Okay. We'll come back to this topic and then let us just understand the points. To a minus x. So when this is when x is negative, if you take the negatives, then y square getting negative. This implies y is imaginary. So no portion of the curve lies on the left hand side of the y axis. Now if when x greater equals to 0, then x greater equals to, for example, 2a. Okay. Then also y square becomes negative. That means y is imaginary again. So no portion will be at the no portion will be there after no portion of the curve lies after, or you can lies right to the right of x equals to 2a. So you get some kind of basic idea. So this is a cusp. You write down. No portion is on the left hand side of y-axis. This is y-axis. This is x-axis. So no portion is there. And if you plot here x equals to 2a, and no portion is there also. So if you plot this asymptote here, no portion is there of the curve. So the only possibility is here. This is the cusp. Now we'll come back to the topic, the question that why we have not considered any inclined asymptote. As you can see that this function, the curve of the graph of this function is lying in this region. So from here to, it will go to infinity, and here also it will go to infinity. So if you take any straight line that is going to cross this line, any inclined line, okay, any inclined line, so that is going to cross it. So any line it is crossing, that is not going to be an asymptote. But this is after writing the graph, after plotting the graph. Okay, but if you go back to check and then you see that idea of what is it called? Inclined asymptote. What happens if we substitute so for inclined asymptote, what we need is we have to put x equals to 1 and y equals to m in the highest degree terms and get I m. So what we have here, x cube minus, not minus, we can write it plus x minus 2a and y square equals to 0. So for the highest degree terms, if you substitute here x equals to 1, and then you try to find out. So those don't have any doubt can leave the meet. And let me just give you some application, some practice problems. So these are for your practice problems. Try to find out the curves. trace the curves